Good day, learners. I am teacher Jessica Alcaraz-Sungguad, your teacher in statistics and probability. We are in quarter 3, week 6, and for week 6, we will be talking about central limit theorem. We have 3 learning competencies for this week, which can be seen in your learning activity sheets. For the explore, match the definitions in column A with the corresponding statistical terms in column B. Write your answers in your notebook and check your answers with the answer key at the end of the activity sheet. Central limit theorem states that the sampling distribution of the mean approaches a normal distribution as the sample size increases. Regardless of the initial shape of the population distribution, if samples of size n are randomly selected from a population, the sampling distribution of the sampling means will approach a normal distribution as the sample size n gets larger. The standard error of the mean measures the degree of accuracy of the sample mean as an estimate of the population mean. It is also known as the standard deviation of the sampling distribution of the sample mean. So for the formula, you have a standard deviation of the sample mean equals standard deviation divided by square root of n, where sigma is the standard deviation and n is the sample size. Remember that if you want to get a good estimate of the population mean, we have to make n sufficiently large. This fact is stated as a theorem in the central limit theorem. So when you say sufficiently large, that should be n is greater than or equal to 30. For the illustrative examples, determine the standard error of the mean for each of the following sample size n, given the population standard deviation of 30. Round off your answer to the nearest hundreds. For number 1, you are given with n equals 30. So standard deviation of the sample mean equals standard deviation divided by square root of n. So that is equal to 30 divided by square root of 35, and that is equal to 5.07. For number 2, you are given with n equals 40. So standard deviation of the sample mean equals standard deviation divided by square root of n, and that is equal to 30 divided by square root of 40 equals 4.74. So take note that we obtain a good estimate of the mean when the standard error of the mean is small. We can say that the mean is a poor estimate if standard error of the mean is large. So in these two examples, we could say that number 2 is a good estimate. Central limit theorem is important because it teaches researchers to use a limited sample to make intelligent and accurate conclusions about a greater population. It also justifies the use of normal curve methods for a wide range of problems. Further, it justifies the use of the formula z equals mean minus mu divided by standard deviation over square root of n. When computing for the probability that the mean will take a value within a given range in the sampling distribution of mean. So where mean is the sample mean, mu is the population mean, sigma is the standard population standard deviation, and n is the sample size. Let's have example number 1. In a study of the life expectancy of 400 people in a certain geographic region, the mean age at death was 70 years and the standard deviation was 5.1 years. If a sample of 50 people from this region is selected, what is the probability that the mean life expectancy will be less than 60 to 80 years? So for the solution, we are given that mu is 70, standard deviation is 5.1, mean is 68, and n equals 50. So z equals mean minus mu divided by standard deviation over square root of n, and that is equal to 68 minus 70 divided by 5.1 over square root of 50, and that is equal to negative 2.77. So using the cumulative distribution frequency of the standard normal curve, locate the area of z equals negative 2.77. So you have there probability of the mean to be less than 68 is equal to the probability of z less than negative 2.77, and that is equal to 0.0028. So therefore, the probability that the mean life expectancy will be less than 68 is 0.28%. The average cholesterol content of a certain canned goods is 215 milligrams and the standard deviation is 15 milligrams. Assume that the variable is normally distributed. If a sample of 25 canned goods is selected, what is the probability that the mean of the sample will be greater than 220 milligrams? So for the solution, we are given that mu equals 215, standard deviation equals 15, mean equals 220, and n equals 25. So you have there z equals mean minus mu divided by standard deviation over square root of n, and that is equal to 220 minus 215 divided by 15 over square root of 25, and that is equal to 1.67. So using the cumulative distribution frequency of the standard normal curve, locate the area of z equals 1.67. So the probability of mean greater than 68 is equal to the probability of z greater than 1.67. So since we are looking for the area above, so we have 1 minus 0.9525, and that is equals to 0.0475. So take note, guys, that when you subtract, when we are looking for the area above, so we subtract 1 from that given area. So we could say that the probability that the mean of the sample will be greater than 220 milligrams is 4.75%. Number 3, the average public secondary school has 468 students with a standard deviation of 87. If a random sample of 38 public secondary school is selected, what is the probability that the average number of students enrolled is between 445 and 485? So for the solution, so our mu is 468, our standard deviation is 87, and mean is 445 with n equals 38. So you have there z equals mean minus mu divided by standard deviation over square root of n equals 445 minus 468 divided by 87 over square root of 38, and that is equal to negative 1.63. For mean equals 485, you have there z equals mean minus mu divided by standard deviation over square root of n equals 485 minus 468 divided by 87 over square root of 38, and that is equal to 1.20. So using the cumulative distribution frequency of the normal curve, locate the area of z equals negative 1.67 and z equals negative 1, I mean z equals 1.20. So the probability that the mean is greater than 445 but less than 485 is equal to the probability of z Greater than or negative 1.63 but less than 1.20 is equal to the area above, which is uh, I mean the greater area, which is 0.8849, minus the smaller area, which is 0.0516, that is equal to 0.8333. So therefore, you could say that the probability that the average number of students enrolled is between 445 and 485 is 83.33%. For the engaged, read, analyze, and solve the following problems. Write your answer in your notebook and check your answer with the answer key at the end of the activity sheets. For the apply, which will serve as your assessment, uh, write your answer on a yellow paper. You have letter A, 5 items multiple choice test, 1 point each. For letter B, you are going to solve the given problem. So A and B is 4 points each. For letter C, that is 7 points. All in all, 20 points. Again, I keep on reminding you, avoid copying from your classmates. That would be all for week 6. Thank you and God bless.